So hello everyone and welcome to the today's webinar. Good morning for the people who are joining from other side of the globe, and good evening for the people who are joining from our time zone. We are from India, Pune-based company, CCTech, and we have developed this platform simulationHub uh, in the 2016, and this is our product we have launched uh, a year ago, Buildings AI. So this is webinar regarding that. So yes, welcome to the webinar. Yeah. So the webinar topic is AI-assisted HVAC system modeling for load and energy optimization. So yeah. So let me introduce ourselves. Yeah, my name is Aditya Roikar, and I am the business head for Buildings AI at CCT. I lead the strategy, growth, and direction of Simulation Hub's building performance platform, that is Buildings AI. And I have spent my career working to develop and deliver high fidelity simulation products and engineering technologies across a range of industries, from wall industry to HVAC and this sustainability industry now. To make them genuinely, my interest lies in simulating real world systems, developing technology, and making it accessible and affordable to the people. Joining me is my colleague, Atharva Jagtap, who is AI technology leader in a simulation hub. Atharva holds a bachelor degree in mechatronics and automation, and his work sits right at the intersection of engineering and applied AI. His interest lies in developing the artificial intelligence, ML modeling tools and products. His expertise lies in LLMs, LangChain, LangGraph to solve complex real-world challenges. He has hands-on experience in building production-grade AI systems, rack pipelines, multi-agent architectures, and scalable model deployment throughout the containerized services and APIs. He is deeply passionate and very active engineer who is contributing using AI and simulation to drive energy efficiency and help industries reduce their carbon footprint. So please join me welcoming Atharva Jagtap. So Buildings AI. So let me introduce you about this platform, Buildings AI, which is industry's first agentic AI platform for HVAC load calculations and energy modeling. So our goal is to uh, uh, make agentic AI technology accessible to the industry. The product and platform are using Energy Plus as an engine, physics solver engine, and many will come more in the future. Then Autodesk Platform Services we are using for data management and visualization. Autodesk Revit we are using for model support and integration. AWS Cloud for running energy simulation, and Simulation Hub APIs for developing this entire ecosystem of the Simulation Hub platform. The Buildings AI is AI-powered human-in-loop platform, which means it's not only AI, but human-in-loop workflows, which makes it different from the generic AI. So all the accuracy, decision-making, and uh, the control lies with humans, and artificial intelligence is used for scaling, accelerating the workflows, reducing times, and it will enhance uh, the users can use multiple scenarios to make you available informed decisions. The platform is currently providing the services like load calculations, energy calculations. It can generate compliance reports. We also provide data management services so that your project data lies secure as well as accessible and at a one location so that you can access it with ease. We also have a CFD module and another product, autonomous HVAC CFD, that also you can explore. The key modules of the buildings there is one of the key modules is PDF to BIM, which is like you import PDF floor plans inside buildings here, and it will convert the BIM model out of your PDF drawings, and it can be used for further in your building energy analysis modeling. Then another is building AI assistant. So along like you can interact with your model with graphical user interface, you can also use natural language to interact with your model so that you can easily access, or you can in a no time you can talk with your model and ask you about any information like what kind of materials are used in my building model, or if my model is in the New York climate zone, then which materials I should choose. So something like that information also you can ask, or suggestion also you can ask. So thanks to Autodesk AEC management models, so that we can easily access all the information inside your building model. Then we have a report assistant, so which generates beautiful and accurate reports from your simulation data. The vast amount of data generates after your simulation. So it compiles and provides you in a structured format so that you can confidently deliver such a kind of reports to your clients. Yeah. So this is about product. This webinar is a part of our webinar series. We are delivering the PDF to BIM, then generative AI for HVAC design and documentation, then peak heating and cooling load calculation, and designing and modeling HVAC systems. So this webinar series is focusing on, for a HVAC designer's perspective, how you can model or design your HVAC systems using buildings here, or how can you model it. So the next or current webinar you will see is, so last webinar was like designing and modeling of detailed HVAC system using manual way in a building there. Now you will see how you can use AI assistants to develop such a models. So yeah, yeah. So hang on. So I'll pass on this to Atharva. Yeah, he'll take you to the next. Yeah.
No. Okay. Am I audible?
Yes, Atharva, you are audible.
Okay. Thank you, Aditya. Thank you for introducing me. Thank you for introducing our product. So yes, welcome guys. Welcome to this webinar. So before getting into this webinar, I'll just need to have a recap of the sessions that we have already discussed. So we do webinars in different domains also, but basically this is a part of a series where we focus on AI and the implementation of AI in age. So I'll just go to the first slide of our PPT. Give me a second. Okay. So yes, as I said, I have to have some recap around what was the first session and what we discussed in that session. So basically, it was around the fundamentals of AI. What is generative AI? What is difference between generative AI and AI? How generative AI is actually being implemented in AEC already, and how you as a user or the domain people of this world can actually learn AI and then start generating problem statements for the software industry. So basically, it was fundamentals of AI and how we have implemented that in AEC or HVAC domain. So if you want to go through the fundamentals, please refer the webinar link. You can go to our YouTube channel and actually have the look at the first part of this webinar. So talking about today, mostly we will be focusing around a feature that we have developed. So the feature is HVAC Design Agent or HVAC Design Assistant. So this feature, actually there is a reason why we went with this feature. So basically, there are major problems that are defined when it comes to designing something. And to solve that problem, we have to have a assisted workflow. So three major problems that we have identified, and the things we will discuss over them. So how this autonomous or HVAC design systems, AI assisted design systems can actually make the design better and faster. The feature that are embedded inside the assistant itself, and how you can use those features that actually would solve your daily problems, and as we can say, how it matters in your actual day. And after going through all these problem statements, we would be able to actually take new problems from your side. Yes, this is the problem that I have in design. It can be of any factor or any domain, and we want to solve it collaboratively. So mostly we'll focus on the problem of HVAC design, how we have built the solution, what we have built a solution, and how it can be connected to other designs would be the part from you, what we expect. So let's first focus on the pains that we have everywhere when it comes to design. So basically four problems. I'll go one by one. So in AEC and HVAC domains, there is the problem of having knowledge or the level of depth you have of that particular thing. So when it comes to design, you have a limited resource which have those knowledge which can actually use for designing a simpler, let's not say simpler, or a complex design which can be actually implemented. So the first thing is the limitation of knowledge, and how an expert can actually implement a design differs from how a newbie will do that. Again, timely. So even if expert is doing that, there are multiple steps that are involved in designing a system, which there is a lot of time lag. So usually user has to get familiar with a tool, any tool, and while getting into that tool, he has to give some form like inputs when it comes to design. Then there are canvases where you import the components and all. There is a lot of time leak, and we are talking about time leak for of a person who has a level of expertise in that field. So the time and the cost of time of that expert is a third parameter that is very important in this case. So we have to see our time, we have to expand the knowledge, and also when we are actually designing all those things, uh, the design, the domain we follow, the HVAC domain we follow, is not a one time thing. So after all these things, also the design needs to be changed again and again, made it better again and again. There can be multiple things which are the problem with this case. Might be the requirement itself changed, might be the market situation is like the components you have selected in the design is not actually available in the market. So there are many things which change real time, where the user has to come to design, update the design, and again simulate the thing. So there are a lot of things involved which are common pains when it comes to a design, and particularly in this context, the design of a HVAC system. So now let's see how we are solving the problem. Oh, sorry, let me correct myself. So we'll first focus what are the problems that we have identified and what we are solving. So again, in the HVAC context, before you run actually a simulation, you should have a HVAC model in hand with you actually. So focusing on this problem, we have narrowed down to four problem statement, which we feel is a pain for the user. So let's discuss one by one. So the first problem is selecting from a large set of components. So you have hundreds and thousands of components available with you in the market, in the libraries of the tools that you use to design the HVAC system. And now it's a very difficult thing for a user to select a particular component. So when you look at a component, it just shows you a high level description of that component. It's difficult, and I would say impossible, to remember what component was designed for what and whether it would suit to my design. So again, you have lot of things in your hand, and selection of components from a bigger library is a difficult point for a design. So let's go to the next point of it. So we assume कि you have spent much of your time, you have selected a component, and now you have to use it. But before actually using the component, you have to again edit the parameters of the component. So it's not like you'll always get a component directly and use it handy in your design. You have to always match the settings or the parameters of that particular component as per the component that is actually available in the market or as per your design requirement. So again, for a particular component, then there can be tens or 20 of parameters that you have to manually adjust with some domain logic involved, which is again time consuming for you. So yes, this was the second problem. Then the third problem. Now we assume we have components, we have parameterized every component, and now we have to keep the wiring intact. Or let's say we have to connect the system. Now this is the biggest problem, or we feel this is the problem which user has to spend much of his time. Connections is very uh, cognitive load, cognitive demanding work. So user has to again place the selected component on the canvas. Again, that should be placed in a correct slot. A AHU can't be placed in plant. So this is also kind of connection. And again, if you place thousands of components in the canvas itself, now connecting those components to each other is the next pain that we have to solve. So yes, this is the major pain that we feel we have to solve. The connection between the components, that too validated. So a fan should not be connected to a, let's say, coil directly or a zone directly. It should be connected in some defined manner. So this was the third problem that we are solving. And then the fourth problem. Let's say you figured out everything. Now connections are also there. But now when you actually run the simulations, you get to know that yes, this was wrong. The parameter you have set was wrong, or the component you have selected itself was wrong. Now there is a gap. So design was in the first three part, and now validation goes into the actually running the simulations. So why not, while I'm adding a component, there should be a system that is telling me you are not making a correct connection, you are not adding a correct component. So that is also missing. So simulation results or the errors in the simulation should be handy when we are designing the system. So we thought as a developer team, these are the four major problems when it comes to design, and we should focus on that. Now let's jump into the actual use case we have built and how it is solving the problem. So, okay, the use case, the faster way. Again, nothing changes. We are not changing anything structurally. The three pillars, the selection of components, the correct setting of the components, the parameters of the components, and the connection are there as it is how we design. We are just adding a layer of AI over it, which can make it faster and reliable. So what design we have made? We have built HVAC Canvas AI Assistant, which sits between you and the actual canvas. You talk or describe your requirement in a simple, plain language, and all the three parts, selection of components, selection of parameters, and the connections, is figured out by the agent. So, okay, this sounds a very low level thing. Yeah, we are giving some prompt, whether the agent is actually designing it correctly. These are the parts that we'll discuss. Of course, this is a complex design, and this is very what we can say, easier to say ki yes, AI assistant is actually doing something, and whether actually it's doing the thing which I am asking to do. So it's the part we'll discuss it in the further slides. But at this point, we should be able to understand that yes, there are systems available which work on just general or plain language prompts and can actually design a complex systems. So let's focus on what features we have actually built under this design. So these are the features which are under hood, which we have built. And okay, we'll go point by point. So yes, again, as I have explained, it's a plain language brief. So you give a prompt, need not to be an accurate prompt. You can be just talking with the actual AI assistant, and it would be generating your design iteratively. So again, we have made sure that whatever inputs you have given and whatever the outputs that are given by the agents are actually validated. So the AI assistant has a validation layer before it gives some output to you actually. So the simulation or the canvas design that is actually being generated by our assistant is actually simulation ready. And if you are happy with the design, you can actually run simulation without actually reformatting manually. So again, the first problem that we have identified, that there was a bottleneck of knowledge. So it's very difficult to pass the knowledge or learn the things when it comes to difficult model designing. So we have also figured this part. So now if you have the intent, if you have the model or the BIM model, you can actually start the design. You need not to know which component you have to use. You need not to know what parameter I should give as an input. So that is figured out by the agent by learning about your model and actually understanding what is your intent to design the building. So if you want to actually over design the building, it's fine with this AI assistant. You can just prompt over the things and you can generate the design. So again, the fourth thing, station and save. So we also know ki HVAC, when we design a HVAC system, it's not a 1 hour task or 2 hour task. Though we are bringing it from a very big chunk of hours to a small chunk of hours, still it will be in sessions. So when we go on a normal chat-based workflows, when we go back to the workflow after some time, it misses out the criticality of the work. So now when we bring this kind of workflow in our domain, where the designs, the complexity of design is very critical, how I can say ki, yes, the agent or the workflow would remember what I have asked in the previous thing and what I have to continue. So yes, we have managed that. We have a session history built for you. All the design inputs that are made to the design are saved. The agent or the assistant knows ki what you have asked him and what would be the potential requirement that might be coming from you. So anytime you can shut down or you can uh, turn off your session, you can resume it any day. That is not the problem. So again, the fifth thing, I slightly address this problem. Yes, I'm asking or I am giving prompt to the AI assistant, and is it like it's directly getting me an output? So it's not like that. So every major point where the actual design needs to be validated, the assistant waits for you. It asks you if something is missing from its side. So if it doesn't know what parameter I should set for that particular component, it will wait and ask you, "Ki, I'm setting this. Is it fine for you, or should I change?" So he's also not dumb. So AI assistant is also not dumb. So it's not like every small parameter for that also he'll ask you. He has a what he has a sweet spot. He knows ki yes, these are some critical parameters. You can also say these are critical parameters for me. I want to set or verify it manually. And if you are fine with what we have put as a sweet spot, then it will auto select for the things which are not that critical, and for critical it will ask you. So yes, it's not making any guess. It actually asks you when it's a critical input to be given. And again, so yes, there is a AI assistant. Yes, it designs for you, but there is always a manual way where you can go actually and enter the details the normal way which we do with other softwares. So yes, there is a normal way of doing this, and there is a AI assisted way of doing HVAC designs. Let's emphasize on that point. Ki, yes, you are saying ki, the AI assistant is waiting for me for the reply, but where it actually stops, and where is the decision, or where the human is actually in the control. So let's get into that part now. So yes, as I said, you are in control or a human is in control. It's your design and it should be always governed and updated, or let's say designed as per you. So basically, there are three review points which we have defined. Again, there are many, but we have designed agent to majorly stop at these points. And the agent will actually stop for your input and then go forward. So I'll just go through the 3 points or three milestones or the three review points which agent stops for you, and you can give your actual input. So the first thing, the selection of components. So it's not like you are just selecting a single component. If you are designing it for a hospital or let's say for a office space, there are multiple components which are to be aligned with just a single prompt. So it shouldn't be a dumb or a lazy workflow. So you have to give, okay, I want a AHU, I want a plant, I want a zones. No, you don't need to do that. You can just say, I want to design a system for an office. And for an office, what might be the main things that are required, that the AI assistant suggests you that. You can ask more. Of course, you can go in detail, but the AI assistant also works for a vague level prompts. So if you can see on my screen, there is a very high level prompt key, what components I have to add, and the AI assistant has said key, these are the proposed components, and this is the proposed layout. So again, you can see the air handling unit, the VAV box, the air terminals are added under the air handling units. Then the chillers, boilers, pumps, and expansion tanks are added under the plants, and the zones which might be present in your designs are added in the zones. So this also matters, what component sits under what major category. So this is also handled by the agent. Now the user reads what agent has produced and actually can can give a go ahead, or can actually ask the agent, no, it's not correct. I have to add these more components, or this component is missing, or any other prompt when it comes to component selection. So this is the first point at which user has the control when it comes to selection of component. So agent is narrowing down the list from thousands to, let's say, tens, and from that tens also again you can refine it. So yes, that was the first thing. Then the second milestone, that yes, now you are good with a component, and now you have to select the parameters or edit the parameters of that component. So agent also helps you here. As I said, it might don't give importance to, let's say, the name of the component. It won't ask you, what should I name the component? It's a very simple thing. But the critical inputs, like what should be the supply air flow rate, if it's not able to put the inputs, it will come to you and ask. And then you can go and prompt, yes, I want to this much of a supply air flow rate, I want this type of fan type, and many things. So there are multiple things that are related to each other. So agent will try to solve major of the problem. So let's say if you define a fan type, it would be able to give other the efficiency of that fan type. So it's again, I'm saying it again, it's not a dumb workflow. It would try to fill in the inputs which are related, which are easy to fill, and it will always come to you when it comes to a criticality. So this was the second thing where agent helps you, or agent waits for your input to actually fill the data, the parameters of that particular components. So yes, again, user may provide the values, or a user can say, I don't know, based on your intelligence, please fill the value. That also works. So the third point, let's take an example. You have added components, you have lot of zones. Now there are two plants, same, both are for cooling, both have same type of system, both have chillers. Now the question is which chiller is connected, or which plant is connected to which AHU. So this is a very user specific question, and ideally the AI assistant should, or the workflow should, wait for the user's confirmation. And yes, this is the way how it is implemented. Wherever it comes to ambiguous connection part, whether when the agent is not able to figure out where this connection might be possible, or where this is connected, the agent waits for you. It asks you where to connect all these components, and then it figures out the rest of the things. The minor connections, let's say the internal connection, let's say I want to add a fan in the AHU, I want to add a coil in the AHU. This also requires connection. A fan, how a fan is connected to a coil, how a node is connected, or the set point manager is connected to a coil. All these things are minor things for this agent, and it figures out those which doesn't have this ambiguity. So yes, this was the third point, where the agent or the workflow stops for the user. It asks the user and then goes further in the design thing. So yes, these were the features that we have implemented, or these were the high-level architecture, where the agent stops, how it works. And now let's discuss as this is a first version of the deployment, the version of this HVAC Canvas AI Assistant, what it is doing, what it has covered, and what is yet to be implemented. So yes, there are four things major four things that are actually covered in this AI assistant. So yes, it supports VAV, CAV, DOS, and VRF standards. So you can use a chilled water plant, you can use a heating plants. There are multiple options where how you can design a water plant. But for now, in plant types, we support water and water-based cooling and heating plants. So you can add zone equipments too. So whatever, let's say you want to add a fan or unity systems or some kind of system that is actually added to the zone equipment, you can add it using AI assistant directly. Using Canvas, you can add everything, but using the AI assistant, these are the features that we support right now. Then again, you can work with SI and IP units. It's not limited that you have to bring everything in one unit only. You can bring in it in any unit, and what is the default unit you have selected, the AI assistant will convert it into the parameters that are required. So again, what is not covered? So building code compliance checks are not yet covered. So design is to be validated by the user right now. This is built on the LLMs or internet's knowledge, and user has to go and check the design whether it's code compliant or not. There is no validation layer yet included. So it doesn't give cost estimation. So whatever the HVAC design he has designed, though it has selected components, but it cannot give you a cost estimation around how or how much would be the cost around designing. So it might go into a ideal system, and the cost might be a very high thing in this case. Then there is no structural and architectural design. So this is a canvas, kind of electrical design. So you have to for now you have to actually figure out the pipelines, the actual implementation in your structural design and architectural design. This system is for designing the system. When it comes to implementation, we are still working on that. And for now there is no MEP coordination outside Canvas. So for piping or we support kind of mechanical, but for electrical and piping, we are yet to go with that features. So these were some things that are covered today, and that some are not built in this version. So now let's see a quick demo. How is the agent working or the assistant working? So you'll have an idea. So yes, this is how our workflow looks like, our canvas looks like. There is a canvas where again user can, oh, you can see my cursor, right? I hope you are able to see my cursor. So yes, this is our UI for our canvas. Here is the manual way of adding a canvas. You can drag the components and you can design it manually. And let's see how a AI assistant is doing that. I'll play the video. So yes, you can actually ask the agent also, okay, what you can do for me, and he has given you some inputs around that. Yes, he can create a HVAC design with a chilled water plant. He can add a AHU with a hot water coil, and multiple things which you actually do when it comes to designing. So let's see what the user is trying to do. Sorry. So now user is trying to add a AHU with a water cooling coil and a water heating coil, and it has a CAV fan too. Yes. So now yes, the user can see yes what is added, and based on that he can if he is good he can go further. So now user is trying to add a cooling plant to the system and is trying to connect it to the cooling coil itself. So yes, cooling plant is added with all the required components, and it is connected to the cooling coil of AHU. So agent is also letting you know what it's doing. So now he's adding a heating plant for the heating coil. Now he's now starting to connect the AHU to the zone actually. So if you want to add the AHU to a zone, you need to have a air handling unit. So yes, he has prompted that. He has added a single duct air terminal unit and he has asked to connect that AHU to the zone itself. Now he's adding set point managers to the system. So yes, final design is ready and user can actually submit the configuration and use this configuration for the load calculations. So this was a quick demo how it's working. You can come to Buildings AI and actually use this thing, and you can start implementing the designs using English prompts or the way you described a system directly. So yes, we saw a demo. Now let's get quite a little in a little depth how we have implemented that, how these systems are built and how the architecture or from software side it is actually working. So yes, so we have built an agentic system. So there are multiple layers of agent that are working underneath. So there is a deep agent against concept of software when it comes to deep agents. So there is a deep agent which understands your context, which knows our software, and which knows what is the actual goal to be achieved. It receives a prompt or a brief from the user and then passes that task to the specialized agents. So there is a swarm of agents. So there are multiple things that are done that are required to be done in parallel. Let's say the filling of parameters in the components. So the workflow is not doing it one by one. So it does it as a swarm. There are specialized agent for every component, and they know about that component, and they know what is the input from the user. And based on that, they are doing that filling that every parameter of every component in a parallel fashion. So again, there is a placement agent, so which knows which component to select and place it where in which slot of the canvas or the design. And then there is a connection agent. So after all these things are filled, the connection agent comes into the picture and actually connects every component which has the which in the required place. So yes, there are multiple layers of agent. So I cannot bring every agent that is working in the background in this slide, but you can just vaguely understand yes, this is the way how we have developed. This is the extendable architecture. It can change at any time. So if you request us, we can actually define it for you. So yes, the outcome is again a validated design, and again when the user is good with it, it can be used for simulations. So at every point there is a review system, we call it as human in loop, and no thing is passed as ambiguous input to the simulation set. So yes, that was about the agentic architecture or agentic system as from the software perspective that we have built. And this is what we wanted to actually showcase. Yes, this is the capability of us as a team, and we can bring this into every critical design. So now let's go into your side of the thing. So what might be the problems that you guys are actually facing today? So these are the problems that we have figured out, and we are very we would be very happy if you come up with the problems which might connect with what we presented today. So these are the four major things again what we see as a problem. So yes, we are trying to solve the problems or the things which are consuming most of your time, which can be actually automated, but you don't see the scope key whether yes, it's an intelligent workflow, it's not just automation. And I feel key I cannot automate it, but yes, it can be automated as you have seen in the workflow here. A topic like a design of HVAC system can be made intelligent. So yes, we want you to reach to us or you bring up the problem statements. which can be solved. So yes, again, these are the four things that we want to solve. We want to see what is the time, what is the work that is actually eating your time when it comes to HVAC modeling. Where does the current workflow breaking down? Where it can be a problem? Sorry, it can be a transfer of work also. So there are two people which are connecting with each other, and when it comes transferring the work, there is a bottleneck or there is a problem with time lag. So then again, there might be things which you think cannot be automated as it might be intelligent, but yes, it can be solved with intelligent automation. And again, there is a common issue with industry right now. Ki whatever inputs are being generated by AI workflows, is it validated? Can I trust it? So I would say please connect with us. We'll help you to build confidence when it comes to AI related workflows. So yes, I expect multiple question queries from you or problem statement from you. Yes, can we solve this problem from this kind of workflows? So yes, let's come together. Let's build solution which can actually help solving the AEC or HVAC domain problems. So yes, this was the thing which we require from you, or we would be happy to get from you. And I would also like to showcase some features that we are building in the next version. We'll bring it soon to the production, and you can actually use the HVAC AI assistant with these new features. So again, multimodal inputs. So for now, as I have showcased, you can just give a prompt. But assume when you are actually designing the system, you might be drawing it on a plain paper. You might not be getting into the complexity of design. That is also fine. If you are designing it on a paper, just click the photo of the paper or the design and upload it. The AI assistant will build the system as per you. So then there is a multi-language support. Okay, I missed one point. So again, the photo was one model, then the other model is voice. So as we are talking, you can also talk with our AI assistant and actually design the system real time. So yes, this is one part of the feature which comes under multimodal inputs, and soon you'll be able to do that also. So the next thing is multi-language. So for now, we are good with English. So the AI assistant is good with English. You can give input in multiple languages, but the output generated is in English only. So we are trying to build or bring multiple languages where the design itself can be done in multiple languages. And then there is design informed suggestion. So again, so for now the workflow itself doesn't remember or learns from you, and we are trying to build that. So when you are using the system will learn from you, and in the next session when you are trying to design a new system or update the new system, it will remember from the past, and based on your new input it can suggest you better designs. So yes, design input suggestions is the third feature that we'll be bringing in soon. So that was about today's discussion about the technology. So I would request Aditya to take this from here.
Okay. Thank you, Atharva, for technology demonstration and capabilities of the current buildings AI features. And yes, as Atharva said, we are seeking pain points that you are facing, and we are open to receive those and build technology around you so that we can better uh, serve you. So yeah, what next? I think Rahul, you can go to next slide. Yeah. So yeah, so we are having offer for the student. So as a standard, if you are a standard user or professional, so you will get a free trial of 15 days. Let us know your experience and how can we improvise this AI workflow. And what Atharva has demonstrated, the platform is not only limited to that, but you can actually model building configuration, building envelope, and you can also get reports. So you can check that by visiting the product and get experience of that and let us know your experience and how can we collaborate and improvise this platform. And yes, yeah. And if you like it, so we'll be happy to serve you next. For students, we are offering 2 months of the trial thing. And how can you access this trial? So scan this QR code or visit the URL provided below. That is www.simulationHub.ai. Yeah. Next. Yeah. Yeah. Otherwise, you can visit to our website www.simulationhub.com. Uh, uh, yeah, from there you can directly click on the start free trial from the subscription page, or you can request a demo from the calendar entry. So you can see what are the available slot and you can schedule a demo meetings with us. Yeah, or you can directly call us or email us or visit to our office. So yeah. Yeah. Now this time for question and answer. So yeah, many of you have provided your questions. Yeah, and if you have more questions, so you can also type, and we are happy to answer those. So Sankar has asked like, does this tool has capability to model and simulate multiple cooling loops in data centers, thermal management systems involving CDUs, pumps, chillers, and adiabatic coolers, etc.? Can it be used to calculate the year-round cooling power used in data centers? So yeah, let me answer Shankar to your question. Yes, this tool has capability to model multiple cooling loops. Yes, and yes, you can also model data center HVAC systems as well. From offices to commercials to healthcare to data centers, any kind of buildings you can simulate using buildings here, and any kind of HVAC system you can model. Yeah, so we are using Energy Plus and Open Studio in the backend, so capability is limited to this technologies. Yeah. So this is yeah. So next question is yeah. So if my client changes the floor plan or requirement in a midway, how easy it is to update HVAC model in buildings AI?
Okay, Aditya, I'll answer that.
Yes, Atharva.
As we have discussed in throughout this session, this is a very agile workflow. So you can anytime come to the app or our product, and you can actually edit the design at any point. So it's a very what we can say easy thing to update the design. So you can use the normal UI as of now, and you can also use AI assistant. So there is as I had quickly showcased some, or Aditya had quickly showcased you what are the other features of this product. So there is also a AI assistant sitting in every module. So you can use those AI assistants also and edit your geometry, let's say, or your BIM model at any point.
Yeah. There is one more natural questions comes to while we using AI. So what happens if the AI gives me wrong HVAC design? Uh, how do I correct it? And can I manually override any part of it? So otherwise, is it possible to edit or a design generated by AI?
Okay. So first of all, the part of AI generating a wrong design. We have made sure कि it follows a standard. So ideally, it would be a very rare case where the AI assistant will actually design a syntaxally wrong design. So it will not connect a wrong component to a wrong component. Or it won't add a wrong component in a wrong slot. So it would never add a plant-based component into AHU. So syntaxial errors won't be there. There can be a domain or let's say business level mistakes. where it might have oversized or given, for example, the supply temperature might have been a very low or very high. So yes, these are the things which might be coming up as a mistake from the AI assistant. And at any time, you can go and edit the parameter or the component itself. So, as I had explained, there are various milestones of the design. At every milestone, the user confirms ki yes, it's a correct design, the parameters are correct. And even if after that, even if after the simulation you see ki it was wrong, you can go in the design and can edit any parameter and resimulate.
Okay. There is one more question from anonymous attendee that how many tokens does each prompt use? How do you control token cost, especially in the case where mistakes are made?
Okay. So again, the how much tokens are consumed is based on how vague is the prompt. So again, there are two layers of tokens which are being consumed, input and output. So input, we don't control. It's up to you what detail of prompt you are entering. And based on your input, the tokens are consumed. The output tokens is what we have engineered. So agent is not generating a vague prompt. It generates a structured output, which helps us to control the limit of tokens that are being consumed. So we have made improvements to the output of the model. We have made improvements on what models to be used for a particular thing, and then we are engineering the token consumptions.
Yes, but Atharva, I think yes. So I'll suggest the attendee who has asked this question. So yeah, reach out to us. Maybe we can have a couple of sessions around how can you engineer your prompt so that your tokens consumption will be less. So yeah, I think Atharva will be happy to
Yeah, yeah.
uh, provide you such his insights using AI. Yeah. There is one more question from Kiran Kumar. Hi, do you have a manufacturer database integrated in this platform? So let me answer. So yes, Kiran Kumar, right now the product is providing generic predefined libraries, which are based on Ashley 90.1 design data, and then what is available in Open Studio and the Revit, your Revit model, so that you can have. But yes, we are having in plan that will integrate manufacturers' data from materials, envelope materials to your HVAC designs, and we'll be happy to know your requirements. So I think. Yeah, we'll connect, and I think I'll be happy to get your requirement. So yeah, I will reach out to you. Are are there any questions? I think let me check. Um, yeah. Can I import my existing AutoCAD drawings directly, or do I need to convert them to specific format? Yes. So I think this question is related to PDF to BIM module. So yes, if you have drawings or floor plans in AutoCAD, you can export them into PDF or image file formats, and then you can import that into PDF to BIM. And if you are using AutoCAD architectures and your floor plan resides in AutoCAD architecture, you can directly import that in Building CI. So we have a couple of uh, demo videos on that. Maybe we can share with you on that. Yeah. Yeah, I think that's it. Questions are over. Yes. So thanks for your time and your questions and your curiosity and interest in buildings here. I think we'll be coming uh, the couple of webinars in this series will complete on design side. So now modeling side is complete. I think next webinar will be on a design side of HVAC system. So yeah, we'll be happy to connect with you again. So yeah, now what's next? Go to our website www.simulationhub.com. Request for trial or request for demo meeting. So if we can show you your, we can listen to you, your requirements about and serve and provide you demo about around your requirements. Other than that, I wanted to say that CCTech or Simulation Hub, we are our parent company. So Simulation Hub is an organization of around 300 plus engineers. We are mostly into the domain of simulations, CAD and AEC industries. We are also partner of Autodesk, development partner. And yeah, if you have any custom requirements also around HVAC or AEC industry, or if your organization has such a requirements, let us know. Our company can serve you. So we are open to custom requirements, or if you want software like this to be white labeled with your branding, we are also open or tailored to customize this solution. Yeah. So that's, yeah, thank you.
Aditya, there's one more question.
Okay. Yeah, Gabriel Oduro, please do you look at transcritical CO2 refrigeration? I think Gabriel, I want to know more about this requirement. Yeah, maybe I think I'll write you an email and want to know more about this requirement. Bye. Yeah, have a nice day, and yeah, we'll conclude this webinar here.
Have a nice day, guys. Thank you.